Okay, differentiating exponential function. Now, exponential function that we're talking about is e. Right? So this is the function that we are talking about. Okay? So you do remember that e is a constant. So it's e to the power of x. So this is the function. So we call this type exponential function. Now, as far as the syllabus is concerned here, it's always e power whatever. So that's where your function is. Okay? So, what is the result of the gradient? What is the gradient of this particular curve? Now, if you recall, how does this curve look like? This curve just looks like this. And what is this number on the vertical axis? It must be 1, yes? Right? So dy dx means the dy dx is the gradient, right? If you plot the gradient, if you draw the gradient on this curve, what do you get? You get itself. Okay? The meaning of itself is dy dx is the same. Yeah? So if you have the original one, the original function which is in black in color, right? Y equal e power x. The gradient, the one in orange, if you draw that and you plot it along, it looks exactly the same as itself. Okay? So that's right, the gradient. The gradient for the function of e power x is e power x, is itself. Okay? Of course, what is it after this? You can actually have more of that function, for example, e to the power 2x. So what is the gradient of this? So the gradient is, again, first of all, because it's e. So if you differentiate e, you get e. And then you differentiate 2x, you get 2. Okay? That's how the gradient look like. If y equals to e to the power x squared, what is the gradient? The gradient of that function of e is e to the power x squared. After that, you differentiate that power, which is x squared, then you get 2x. Okay? Of course, you can. Since you learn trigo, you can do e to the power sine x. What is the gradient of this? It's e to the power sine x and then cosine x. You can do anything. Alright? So if y equals to e to the power tangent x, or if you like, how about tangent square x? It would be dy dx. First of all, would be e to the power of tangent square x. After that, you're going to differentiate tangent square. It's 2 tangent x. After that, you differentiate tangent, you get secant square x. So things like this, then you need to do a product rule. Okay? Because the function of x is one function, and then e to the power x squared is another. So they multiply together, so this is a product rule. Okay? So then you do your normal. Alright? So let u be x, v be v to the power x squared, and what is du dx? 1, what is dv dx? E to the power x squared, and then 2x, yeah? Alright? Okay, and then what is dy dx? So it's v du dx, which is e to the power x squared, and then you add 2x squared e to the power x squared. and you see that the x squared is the same, or rather that's a common factor,